All right, hello everyone. Hope you're having a fantastic day. Pretty sure I'm live. Yep, looks like it. Okay, this has nothing to do with what we're doing today. I was just reading this. So what we're going to do today is we're going to use, well, first we're going to try to move the Raymarching shader to a compute shader instead of a fragment shader. So I was looking at it. I'm in the wrong project. Hang on a second. I was looking at this shader and I noticed a couple of interesting things. I tried doing texture fetching again instead of bit field, which is in this SDF shared. So there's sort of a bit field in here that I was using as well. I've tried both. It looks like bit field is maybe slightly faster, but both of them are having problems because I guess of the way this shader works. So every single pixel is going to fire out a ray, right? But there might be, actually I'll draw this. Let's just say these are our voxels we're looking straight on. Let's say we fire a ray here. Well, we're going to be firing a ray everywhere, but let's just say our pixels are really far apart or something for some reason. Anyway, a ray here, a ray here, a ray here, here. All of these, they're all going to use exactly the same result from this calculation here, map local, basically. So they're going to use the, well, they're going to use slightly different, actually. The p value is going to be different, but a lot of these other values are going to be the same. And so we're essentially doing tons and tons of recalculation of all the surrounding voxels for every single pixel, even though we could just cache them, like especially looking up if they exist. So voxel exists. We're going to look up, we're going to check if this voxel exists, right? And every single ray in this square is going to look up, hey, does this voxel exist? Hey, does this voxel exist? Hey, does this voxel exist? Which is apparently really bad for memory because they're all on separate threads and they're all accessing sort of random, although it's like a 27 block, but it's sort of random access, for these ones, because rays down here will be accessing these neighbors, right? And they could be happening at the same time or at different times or whatever, and then the cache is getting absolutely destroyed. So we're having a lot of cache misses. So let me just see if I can do a little trace here. I've been learning how to use this a little bit. There's a lot about GPU architecture that I don't understand yet. I'm going to get an... Oh, hang on a second. Okay. Okay, before I do that, I'm going to limit the frame rate because I think that could be, hopefully, why we're lagging so much. So if I limit the frame rate to 60, or actually 120, it's my monitor's frame rate, that's the wrong folder. Okay, we just build here, and that's all good. Now, hopefully when I launch this, I'm not going to get OBS complaining at me. Let's see. Get out of the way. No, it's still overloaded. Okay, so I just did the trace and closed it. That's going to be a little bit annoying. So I might have to go back to the little window. Yeah, hey Dandy, how you going? Yeah, OBS is getting overloaded, so I'm just going to leave that closed because we've done what we needed to do, which was basically take the profile. And now, should be able to see in here. I'm still learning about what a lot of this stuff means, but I can see, where is it? Down here. The L2 sector hit rate overall is 64%, which is maybe okay, but if I go to our specific draw command here, which is for the Raymarching, it's only 27%, which is really bad. That's actually higher than I've seen before. So before it was like 15 or 20. Alright, so already we can kind of guess that, okay, we need to change either our memory access patterns or we need to cache something. And my idea is basically to move this out of the fragment shader. There we go. Move this out of the fragment shader, and we're gonna cache results of particular rays and then do a local memory lookup. I think that's something that you can do. So if I look at compute shader, Vulkan compute shader local memory. So the shared memory accessible by all invocations within the same workgroup. Okay. So I kind of want to see documentation. I guess I'll just use a guide then. Let's have a look. That's right. Go to cache the raise so you can raise the cache. That's right. Exactly. So I've got a work group here. Let's see. For compute shaders, there's a split between individual elements in work groups, which are groups of individual elements. Elements within the same workgroup can do features such as accessing workgroup local memory in a fast way, which is useful for many operations. So that's this local size. And then let's have a look. Is there an example of local memory? There's a read-only buffer. No, that just looks like a normal buffer. I don't see anything to do with local in here. Okay, I will have to find another example. Let's see if this one has anything about it. Local. So that's a host local buffer, which is not exactly what I'm looking for. At least I don't think so. Okay, local sizes, that's all good. Okay, nope. I'm looking for some way to, fetch and store local memory. It's got to be in the GLSL, right? Or is it just buffers automatically shared? Local memory compute. Shared variables. Okay, that's OpenGL though. But they're okay, Vulkan supports shared buffers. They are better described here. Okay. Okay, shared memory. Memory barrier shared. Group memory barrier. Okay. Incoherent memory accesses. So we can write. Okay. They're called incoherent because these operations do not use the normal OpenGL memory model, which is normally coherent. Okay, we're not using OpenGL, but where's that Vulkan documentation project, I think it's called. Maybe there's something in here. Okay, I'm looking for, let's see, shaders, kind of. Compute. Compute is not a thing. Compute nodes. Compute shaders, there we go. Okay, invoked via dispatching commands. They're formed from groups of work items called work groups and processed by the compute shader in the current compute pipeline. Yada yada yada. They execute in global work groups which are divided, given a local size and ID. Okay, they can share data with other members of the local work group through shared variables. Okay. I need to look up shared variables. Doesn't look like they have anything about it. And issue memory and control flow barriers to see. Yeah, but where do I look this up? Okay, dispatch command. Yeah, great. Could be that it's not going to be on this website because I guess it would be a GLSL feature. Shared variables. Here we go. Maybe the OpenGL wiki comes to save us. No, this is not the wiki. What is this? Okay, what do they got? Okay, local, binding 1, atomic add. Shared. Okay, so you just use a shared keyword. It'd be cool if that was listed somewhere. Shared. GLSL keyword. Type qualifier. Here we go. Variables declared with a shared qualifier are shared among several shader invocations. Such variables can only be used in compute shaders. Shared variables are shared among all invocations in a workgroup. Alright. Was I? Oh my god, I'm so stupid. I was looking at this earlier, but then I clicked this link. Okay, great. So, you cannot declare any opaque types as shared, but aggregates like arrays and structs are fine. Okay. These values are uninitialized. Okay, that's fine. Also, the variable declaration cannot have initializers, so this is illegal. Okay. Only one invocation can set the values. Due to this. Okay. Okay, so we can use like GL invocation ID or something. Equals 0. To make sure that we're on the right thread. Then a barrier. Then all of the remaining ones can use that thing that we just constructed. So I guess the only way this would be faster is if we've got our first invocation that populates the cache, and then all of the other invocations can use the cache at the same time. So this full time has to be faster than if we just don't, obviously if we don't use the cache and everything just uses its own, keeps doing the calculation over and over again. I mean, that's kind of obvious to say, but you know, caching might be slower if it's faster to do the calculation, but I don't think it's going to be in this case. We'll see. So we're going to cache voxel exists because that's what we're having a big slowdown on, I believe. Let's have a look here. Go to the source code. And that's not the right one. We need, which fragment shader is it? This one? No, this one. Yeah. Okay, so there's a lot of time being spent on this, which is, what's LGSB? LGS8? Long scoreboard. So float 32 comparison is taking a really long time. I guess it's because, hello. Yeah, I don't need you to, there we go. Stall reason is long scoreboard. What does that mean? Memory bandwidth. They're waiting for their data read to come back from memory. Okay. Okay, so basically, because of this texture call, we're having a big slowdown here. And this one has apparently got to do with branching. Control flow, but I'm going to leave that for now. We'll worry about the memory. That's the biggest thing that's going on. So we can't use shared variables in a fragment shader, which means we've got to move basically this code into a compute shader. And then set up the pipeline. Man, there's a lot of work to do. All right. Let's get into it, I suppose. So first things first, we're going to make an SDF comp GLSL, I guess. So we need this layout, local size, X. I think that's what it's, that's what the syntax is. Let me see, compute shader, local size. Yeah. And this is an in parameter apparently. So I didn't really think about this, but all local variables are going to share, all local instances are going to share the same cache. So how many do we want to use at once? So basically we're doing the thing that a fragment shader would do. Our current resolution is 1920 by 1080. So let's see. I don't think I should do more than 16, but if I do like 16 by 16 pixels, I guess I could do 16 by 16 pixel groups. That might be fine. And then how many times am I going to have to run the compute shader? I'll just try it with one group first. So we'll just do a 16 by 16 group here by 1. I don't know if you have to specify that, but maybe. We need basically all of this stuff. We don't need the out variable. We need the UBO. We need the world texture because we're going to sample from it. We need the inverse projection view matrix. We don't actually need this other stuff. Maybe. I'll just grab it anyway. So SDF numbers is used to, actually we do need that. That's used to reduce the amount of rays. But I'm probably going to change how this works. I'm going to use a sparse voxel awk tree, I think, in the future. But for now, we'll just continue with this. We don't need the bit field because we're going to use the texture. Okay. Now, actually, maybe I should test. Before we do this, I'm going to test the bit field version again. So sorry, the stream is going to lag for a second. All right, done. Let's have a look at that. So we're going to go to the Raymarching. Here it is. And we've got, where's the L2? L2 sector hit rate is 40.9%, which is a bit better. So maybe we'll use the bit field and not the texture. I'm not sure, because you can encode more data in the texture. Besides just exists or not. Well, so this is interesting. There's a pipe called XU. I think it does bitwise stuff. And it says that it's got a bit of a slowdown. Oh no, that's not bitwise. What is this? Min and max. Okay. It does not do bitwise things. Why was I thinking that? Special function is a family. I don't know what that means though. Well, anyway. As you can see, the bitwise version is a bit faster. For now. Or at least less cache misses. I don't actually know if it's faster. That's fine. We'll stick with that. Why is this on the middle of my screen? Okay, so we'll use this bitwise version here. That's not what I copied. There we go. We need the time. We need smin, SD. We don't need SD sphere. Maybe actually before I do a full implementation, I should just try to draw something on a frame buffer. That would probably be the best thing to do. Let's just do that first. I'm just going to delete this. I'm just going to have a main function. What the hell? I'm going to get the X and Y position, which I guess is just going to be the local invocation ID dot X. And I guess I'll just add a half value to that so that when we use it, actually, I'm not sure. Invocation ID dot Y. Okay. So we need to output to something. I think we can do that with RGBA8. Let's have a look. GLSL layout RGBA8. Is that a thing? It's an image format, image uniform variables. Define the format that all reading operations will convert the data into, and all writing operations will convert the data from. Yeah. Okay. Image store, image coordinate, and data. That's good. Okay. I need to know what the uniform is. Is it like this? Yeah, RGBA8 what's UI? I'll have a look up there. Write only, uimage 2D, some image. I think this is what I want. Oh, that's an RG16F. Huh. Well, I probably just want RGBA 32. I thought that was 8, right? RGBA8 I. Unsigned. Yeah, I guess I do want this one actually. It's an 8-bit unsigned image. Is that what it means? The I on the end? Or do I want unorm? Is it unorm? There's snorm. Alright, I'm just going to go with this. So, we just make a uniform binding. I think this syntax is going to be a bit different, but I'll try this. Okay, so layout RGB8UI binding equals, I guess I'll just put it on binding 0. Write only image 2D, U image 2D. Okay. Image. Alright. Wait, is that a keyword? That might be an image. I call it out image. Okay, now what I want to do is write to this image. So I'm just going to say for, let's just say, this is going to be 0 to 16, and there's going to be a push constant maybe. Push constant, which is going to have, what do these ones have? Unused right now, except it does not actually unused, it's got the time in it. I can use that. So I'm going to need the inverse P projection matrix, so I will keep that here. And then I'll say vec for time and position or offset. Time and offset 2D. So there's actually one extra component I could use there. And then I suppose I'll just leave some more unused. Just to remind myself that I have the space here. I'll call this pixel offset equals time and offset 2D dot YZ. And time is time and offset 2D dot X. I suppose it would have been less confusing to swap those, but anyway, it's all good. So for I suppose we'll use int I equals 0. Actually, we should use float. Should we? No. I don't like that. I is less than 16, I plus equals 1. Why am I making this I? This should be X. Should it? Or should it be Y? So this is local X and Y. This is, actually, you know what? I'll leave it as I. Okay, so this is going to have a simple loop here that loops over a 16 by 16 grid and then adds X plus equals I and plus pixel offset. Or actually, in fact, we could make this a vec2, that would be a bit easier. So to say position vec2 is this and this to get together. Okay. I think you have to cast these. I don't know what they are by default. Probably an integer of some kind. Yeah, and then we got, so that's the local position. Pos is going to be local pos plus pixel offset plus vec2 ij. I think that will work. Actually, I don't need to do this loop. What am I doing? It's going to be handled by the invocation of 16 by 16 threads. Okay. But we are doing 16 pixels per thread. But it's per work group, not per thread. It's per work group. Okay. 1 pixel per invocation. Okay, got it. And then, so that's going to be our pixel position, I guess. Then we just want to do UV, I guess, equals pos divided by, now we need to get the width from somewhere. Image, sorry, UV dot pos dot x divided by image width. Pos dot y divided by image height. Now where are they going to come from? I guess I can pass them in. Image size. Okay. So that's our UV coordinate, and then we can do, what was it? Texture. Not bind image texture. That's not geo image store. Is that a thing that exists? Maybe. Some image. So out image and oh, hang on a second. Is that the pixel coordinates? I'm gonna have a look at this. Hello, Alex. I'm working on porting the Raymarching code that I have from a fragment shader into a compute shader, because then we get access to things like local memory, which can help with the current issue, which is L2 memory is not being utilized well enough. Where is it? I think I was just on it. The L2 sector hit rate's only 40%. That's actually higher than I've ever seen it. It's usually around 15 or 20. I just think that's because we need to have local memory so we can get stuff. So this P value here, it's a coordinate. It's not a UV coordinate, I think. Which means I don't need to do this part. I can just add the position here. And then we're going to store some value. Green, blue, RGBA 8 UI. Is that really the format that I want? Whatever. We will figure it out. So I'm going to put in here vec4, and it's going to have just red. which I think we can do. It's between 1 and 0, right? Let's see, what do they put here? No, this is... Oh, interesting. So it's 8-bit integer. Okay, that's weird. So 255, 0, 0, 255. Okay, actually that's going to be blue. I think we need to... Oh no, we can use RGBA, that should be fine. Just in the final frame buffer, we need to use BGRA because we're on Windows. Okay, I think that should be enough to just test this. Also, I need semicolons. I think that's the right name as well. GL local invocation ID. GL local invocation ID. Yeah. Okay. Let's see if we can. How do I get to work on something like this? You're so tired of meaningless work at Amazon. Well, this is not my job. Well, it is my job, kind of. I don't know the answer to that question. Take a lot of risks. Lose a lot of money. Preferably not the second part. I saved up for like maybe 3 or 4 years, maybe a bit longer. I saved up, actually maybe it was longer than that. I saved up for a while and gave myself enough money to work on whatever I wanted for like 4 years. But then I spent 4 years playing video games instead of doing anything productive. And then I was like, okay, well, do I want to go back to working 9 to 5 or do I want to do something else? And I decided to do something else because, well, a few reasons, but you know, I had a baby, now she's a toddler. It's pretty hard to get a job when you can only work from home or you can only work like 3 days a week. Working in tech is pretty impossible at that stage. And the other thing is I have lots of gaps in my resume now, and people don't like that. So I don't think I'm very employable at the moment. Okay, so this is not valid. Unrecognized layout identifier or qualifier requires assignment. Alright, so maybe that's only for OpenGL. Let's see, Vulkan, GLSL out, write to image. Drawing to image from compute shader. Great. Okay. RGBA 8. Okay. I will try that. RGB. Oh, I don't know what the value is going to be there. Unrecognized layout identifier. Requires assignment. E.g. binding equals 4. Okay. Oh, did I miss the A? Okay, so that part's done. UImage2D sampler types can only be used in uniform variables or function parameters. This is a uniform variable. I guess I need to write uniform here. Uniform. Great. RGBA 8 does not apply to unsigned integer images. Okay. I don't quite understand what that means. That needs a semicolon. Right. I guess I need to just change this to image2D. Okay. Now we got more errors. Push constant only. Oh, I didn't make a uniform. This is a uniform. There we go. And geolocal invocation ID is undeclared because I missed the capital D. So many typos. Y vector swizzle is out of range, line 21. That's because that's the wrong ID. Image store, no matching overloaded function. Alright, so this function doesn't exist. I need to make, or maybe it's the parameters. Cool. Let's have a look. Yeah, this guy's got a code example. Let's have a look at that. Okay. So I want to look at the GLSL file, which I think is this one. So he's writing to an image. That's good. That's what we want to do. He doesn't even have a type specified here. Interesting. I guess that's optional. Oh, so image store does exist, but he's putting in a vec4. Yeah. Okay, so this actually, I think, well, that's not going to be the problem. I think it would just be an error, right? This is a vec2, but it should be a I vec2. Right, alright, okay. So I will just make this an I vec2, I guess. Okay. And now the shader compiles, but we haven't done any of the setup for it, so... By the way, I was not promoting taking 4 years off work and then playing video games. That was one of the worst decisions of my life. Because now everything is much, much harder to do. Whereas those 4 years was super easy and I had so much time. I didn't have a family. Yeah. What's this? Apparently debug does not exist. Really? I can see it right there. Debug vertex SPDB. Oh, okay. Weird. The language server was messing up. Alright, so we've got to make a new pipeline here. You kind of did the same, but you were traveling for 10 years. Yeah, fair. It looks like I'm behind peers who did not. Yeah, well, something I didn't mention is before those 4 years, I also spent the previous 15 years doing basically the same thing, except I didn't have money. So, yeah, not great. Yeah, it kind of sucks to start your life in your 30s when everyone else started in their 20s. Well, not everyone, but a lot of people. So I try not to compare myself to other people as much as just comparing to what I used to be like, which I find to be a lot better. Let me just remove this guy. Yeah. So if I look at what I used to be like, which was pretty bad, lots of drinking, lots of partying, drugs, no responsibility, and yeah, just not really in a good place. Then I'm doing pretty well, I would say. So we need to make a new pipeline, but I haven't extended the pipeline create function to be able to make compute pipelines yet. So you don't think it's that bad? I had a good time. Well, I didn't really have a good time though. That's the thing. Like in the moment, especially if you take illegal substances, it feels amazing. And you think, well, you don't really think it, but you feel like you're having a lot of fun and having a great time and everything. But really, it's kind of empty. Well, at least that's my experience. Alright, so we've got a compute pipeline here. I might just copy this. Just do it the quick and dirty way, and I'll extend that function a bit later. So we need some descriptors. We need to make the shader module, make the pipeline layout, make the compute pipeline, allocate the descriptor sets. That's all good. Update the descriptor sets. That's pretty much it, actually. So we'll just grab this. So a bit of code, but not, you know, too much, I guess. I will put it here. Create SDF compute pipeline. So we do need an image, but it's gonna be, we're not sampling the image, right? So this is an image 2D, it's not a sampler. So it's some kind of image, maybe a storage image. Available in the compute shader. We don't need a storage buffer, at least not right now. We're just gonna go with the minimum requirements here. So that's all fine. Let's see, descriptor set layout. Okay. Now, this needs to be on the context. SDF compute descriptor set layout. We'll just do something like that. This is SDF comp. Okay. Yeah, but if I were to give someone advice on how to get out of whatever it is that they're doing, kind of depends. If you've got the interest, or maybe you'll find the interest, but if you look into marketing and sales, it's actually way more interesting than I thought it would be. I always thought salespeople were sleazy and it's all like weird and you know, like tricking people, or it requires a lot of extroversion, and I'm really introverted. But once I got into it, I was learning about copywriting, which is basically the process of writing sales material, like writing an ad or writing a letter or whatever, just to basically convince people that what you have is worth their time and or money. It's actually kind of interesting because there's all these techniques and there's methods and different rules and stuff and different ways people react to different words. So it gets kind of technical, which I think is pretty cool. Yeah, I kind of wanted to take a sales job, but just to really get the experience of doing that, but I haven't done that yet. Maybe I will. I need this to be on the context as well. And the point I was getting to was that if you can learn how to sell something, then you can probably use that skill to make money instead of whatever it is. If you change, if you change a career when at the senior level, you have to take a huge pay cut. Yeah, well, I wasn't really thinking about money in that kind of way. Just like more like getting out of the corporate sector, I suppose. Descriptor set layout. Do I need that later? Or do I just need the descriptor set? I don't think I need it later. Let me see. I do. I need to bind it. Okay. Yeah, I mean, I guess it really depends on your situation and everything, right? So I was making a lot more money when I was a web developer, but I didn't like it. And I decided to take, well, a big risk and make no money, and do my own thing. And I don't know if it's going to pay off. I guess we'll see. Is this NeoVim? No, this is Helix. It's similar to NeoVim, but it's got, well, it's got a different model. So you select first, and then you do an action on the selection, rather than the other way around. So this is not what I want. I don't need this sampler, although it is going to be an image. So we're going to do image, storage image, binding 0. That's good. We'll just delete this one. And it's not a sampler. I don't know if I need that. Maybe I do. What does this say? P buffer info, image info. Don't use the mouse at all. I use the mouse when I'm explaining stuff. So I'll like, you know, just move the mouse around, but no, not when I'm programming though. I'm not reading to it though, we're writing to it. What do we got here? Presenting source. Yeah, there's a lot of extensions. I don't know, is it general maybe? Actually, I can just check that other guy's code. He was using Vulkan, right? Let's see. KRUs. Let's see if we can get something going here. So we've got Vulkan environment.h. Hello triangle, maybe probably this one. C++. I don't know what's happened. My mouse is breaking. Okay, I guess I just have this cursor now. That's fine. Right, so I want to know about the descriptor sets. Okay. Descriptor set layout binding. No, that's not what I'm looking for. I'm looking for the right descriptor sets. Here it is. Okay. Binding 0, one of them, yeah. And it's the image info, which is here. No sampler. It's wrapped. You have to look up where he uses this. Update descriptor sets, compute image binding, swap chain views. Okay, so he's using the swap chain image directly. I guess that makes sense. Okay. Compute image binding, where is that defined? Okay, it's 0 until when? Oh, it's just 0. Okay. So general, I'm going to use the swap chain image. Alright, we can do that. So I don't need this right now. I think I need to do this in the loop. Is this in the main loop? It's in the main function, but it's not. Doesn't look like it's in the main loop. Oh, because you can just do it. Of course, you can just write to it first, I guess. Swap chain image views. Okay. Really hard for me to understand this code. Okay, so he goes through the command buffers and records rendering passes. That's all good. Whoops. Okay. So it is in the record image barrier. Okay. And then submit to queue. Okay. Rendering. Okay, got it. I haven't really done it like that before, but okay. I suppose that will work. I think. We still need to allocate the descriptor sets though. What are they called? This is, it's not compute pipeline, it's SDF compute, and that means this needs to change to SDF compute pipeline layout. It does use this descriptor pool. It's going to use the SDF compute pipeline. Okay, all right, I think that's good. So I need to make these variables now. So I need descriptor set layout, pipeline layout, pipeline, and descriptor set. So descriptor set, pipeline layout, pipeline, and what was the other one? Descriptor set layout, which we don't usually need, but if we're going to update them in the main loop, we will need them. So this is going to be SDF compute. This is not graphics pipeline. This is just pipeline. Okay. What's the error? Layout is layout. This is going to be SDF compute pipeline layout. There we go. Very good. Okay, now hopefully we have a compute pipeline. We're going to need to do the update descriptor sets thing. Which is fine, we can do that in the main loop. So I guess at the end, I'm gonna see if I can do it here. So I'm gonna add red square to frame buffer. That comment is actually kind of useless, but anyway. So I need to bind compute SDF compute pipeline. Okay, what's wrong with this? Is it bind compute pipeline? No. Am I crazy? Oh, it's command bind pipeline. Okay. Command bind descriptor sets. Now, do I want to bind them now or update them first? Update them? I guess I update them first. I still have to do this anyway, so we'll do this. Compute SDF descriptors. No. Compute pipeline layout. There's going to be one of them. It's going to be the SDF compute descriptor set. I made a typo. And 0 and nil. Okay. Now, the problem is what? Expected a comma, got a new line. What did I forget? Oh, I added 2 commas. There we go. Now it's going to complain this doesn't exist because it's a typo. Now we need to update script. I'll just write the command update descriptor sets 1 and descriptor. I guess I'll call it write descriptor set. Okay, and we'll call it copy count 0. So these are write descriptor sets, and they need to have this type. Okay, I'm just going to copy this from somewhere. There we go, and this is going to be an image, storage image, descriptor count is 1, no buffer, we're doing image. Here we go, so sampler is going to be nil. Actually, just don't even include it. Image view is going to be the image view that we're currently using, so it's going to be va context dot swap chain image views. Image index. Image layout is going to be general. Okay, I think that should work. What's the problem with this? Can I assign? Oh yeah, right. This needs to be raw data. Okay, and this has a problem because what? Invalid compound literal type descriptor image info. Wait, what's wrong with this? No, it needs to be a pointer, right? Is that not what I needed? Oh, God. I failed to read. Descriptor image info, right? I even said it out loud. There we go. Okay. Now that should update the descriptor sets. That's good. Now do I want to update them and then bind them? Probably. I think. I don't know which order that's supposed to happen in. But anyway, we can grab... Actually, I'm just going to grab this from up here. Push constants. And we're going to put in SDF. I want to make a compute push constants, which is slightly different. It's going to be on the compute pipeline. Compute stage, rather. And then dispatch. There we go. So we're going to dispatch. What was it? I'll just do 1. We'll just do 1, 1, 1. And we'll have a look at what that does. And then we can do... what do I need to do after this? I need to wait. I need like a memory barrier. Is it memory barrier 2? This looks so much more efficient than VS Code. Well, maybe. I know that I would not be very efficient in VS Code because I'm not used to it, but I got a friend who's a senior engineer and he swears by using the mouse. He just uses the mouse all the time. Says it doesn't really make a difference to him. So this is going to be, is it top of pipe? I guess, yeah. Just source access mask is shader, right? I need to look this up. I can't remember what it's supposed to be. So this is supposed to be, destination is going to be not sure. Okay, I'm going to have to look this up. Memory barrier, actually let's just look at what he does first. He does do a memory barrier. He uses a memory barrier 1 called image barrier. Okay, record image barrier. It's used in several places here. Let's see. Okay, so color attachment. Oh, I already have a function for this. What am I doing? It's right here. This function. I don't know if I have to do anything. I will just leave it. I'll probably get an error. So we'll go up to push constants. Where is it? Here. Change this to compute. And we're going to put in the inverse. Yeah. Here we're going to put in... That was kind of funny that I did it that way. Actually, you know what? Maybe I'll make it 32 vec 2s instead. Oh, 32 vec 4s rather. And then, no, but I need the first one to be matrix. I just want to write out a whole matrix here. I guess I could do this. SDF compute push constants. Here we go. 1, and then what did we say we're going to store in there? This stuff. So 1 0 0 equals time since start f32, and then offset 2d. So it's going to be 0. I'll leave these commented here for now. Okay. Then, so that'll be the first matrix, the first row, sorry, first matrix, second matrix, first column, first row. Yeah, I think that's right. Okay, and then this one is going to be, instead of just the time, we're going to do image size. So that's going to be window width window height. What's wrong with that? F32 cannot be used as a compound literal with fields. Oh, okay, this is incorrect apparently. Oh yeah, you got to index it like this, I think. Is that right? What's wrong with this? Oh. Let me think about it. So it's actually 4 vec4s. Yeah, what am I doing? This is 4 vec4s, not 16 vec4s. Time since start F32 is apparently not... Oh, there we go. Alright, that should be correct. Now, it's definitely going to be broken. And what I'm going to do is I'm going to disable the Raymarcher because it's really expensive and it makes the stream lag and we don't need it right now. So that is this one. So I'm just going to not do that. Okay. Alright, we got an error. That's what I expected. But what was the error? Create compute pipelines has a push constant buffer block, which is outside the pipeline layout range of 0 to 16. Oh, I made it a different size. Okay. What's the other error? Allocate descriptor sets. P-set layouts must be valid pointed to an array of descriptor set count. Okay. So that would be this one. Descriptor set layout. This is the wrong compute shader actually. Where is it? Yeah, it's this one. Yeah, so this is incorrect. This needs to be vk context dot SDF compute descriptor set layout. Okay, I think that will fix that problem. The other one was the push constants. Okay, so we'll make the pipeline. Yeah, where do we do that? Create compute pipeline here. Layout is this. Layout info is here. Push constant is only 1 vec4. Yeah, there we go. So this will be 2 matrices. There we go. Okay, now what? Well, another error. What is it? Okay. In the descriptor set layout, descriptor type must match the type of the destination binding within the destination set. Okay, so I've got the wrong type here. Where is it? Storage image. Okay, that looks fine. Binding 0. Unless it's not storage image. What does this guy use? He does use storage image. Yeah. Okay. So let's see. Descriptor set layout. Ah, yeah, that's the problem. No, that's not a problem, actually. That variable is just not used. Okay. So it's usually when I update the descriptor sets, which is down here. Storage image, yeah. Destination binding is going to be 0. Yep, that's fine, isn't it? Binding 0. Okay, I'm gonna have to run this again and read the message again. Where is it? Yeah. All right. So the object with this handle, which is of type object type descriptor set, Object 1. Okay. Oh, so there's two objects. One is also another descriptor set layout. And we do VK update descriptor sets. With the storage image is different from the binding descriptor type, which is uniform buffer, which is from this descriptor set here. That's the same handle as this. Okay, so somewhere we've said it's a uniform buffer. Okay. And then this one probably, oh no, this is a different error that we need to resolve. So image view is created with transfer source bit usage color, but we need to also have storage bit. Okay. Let's fix the first problem first. So there should be uniform buffer somewhere. So this descriptor set is wrong. Wait, no. Yes. This is the debug descriptor set. We want the SDF compute descriptor set. Well, that's probably the problem. Okay, great. I think there's still an error though. Yeah. Well, at least we're rendering. Now. Okay, so layout general doesn't match the previous known layout, which is color attachment optimal. The image layout must match the actual image layout. Yeah, okay. So where would I look at that? This one, general. So this would actually be color attachment optimal, I guess. Okay, still problem. What is the problem? I used to be so scared of these errors, but they're actually really good. The only thing I wish they had was line numbers for which invocation of the function it is, because it just says something like the function is VK update descriptor sets, but I don't know which one that is, you know, because I called that like 5 times. Let's see, validation error. I'll just read from the bottom to the top. Push constants in the compute bit, overlapping offset, size equals 128, does not contain the stage compute bit. Okay. We'll fix that problem. Actually, let me see, what's the other error? Okay, what about this error here? Push constants, okay, it's all push constants right now, okay. So, if we have a look at the push constants for this, which is going to be in the pipeline layout. That's the wrong pipeline. See what happens when you copy and paste code. Okay, what's this error? This is the image view. It says that it was created with transfer bit and color attachment bit, but descriptor type is storage image. The Vulkan spec states that if descriptor type is storage image, the image view must have been created with usage storage bit set. Okay, well I guess I can do that temporarily. I probably don't want to do that permanently because I have a feeling there's a penalty. I don't know for sure. But it would be somewhere here, swap chain, storage. Okay, now there's another error. Oh, look, we got a red square. That square is being drawn with the compute shader. We have errors. But that does mean that it's working though, which is great. I'll just pause this so it's flickering, which is annoying. Okay, so this says okay, so let's see. Update descriptor sets. Image layout is color attachment optimal, but descriptor type is storage image. Allowed layouts are general or shared. Okay, so this is when we do update descriptor sets. So I think I need to transition it from storage image back into color attachment after I do that. I think that's what I need to do. So if I go down here, where is it? Oh man, it's what should I look for? SDF compute. Just go to the bottom. Here we go. So after this, I was saying I need to transition the layout. I think I need to transition it here. Although it doesn't really make sense to transition it twice, so previous thing is general, right? Hey Ant, how you doing? Ant says, hopes you can learn GPU programming someday. Yeah, it's pretty cool. I wish I started learning graphics programming like 15 years ago. I think I would have done well. It's way more interesting than I thought. Is that gonna work? Maybe. Let's see. Alright, well, still got a problem, which is can't transition this layout when the previous layout is color attachment optimal. Okay. So it's already color attachment optimal. What was the previous problem? I guess I'll change it back and I'll see. So we'll just uncomment this again. And pause this and have a look here. Oops. And the weather's looking really nice today. Right, so the image view image layout is this, but descriptor type is storage image. If descriptor type is storage image, the image layout must be of a list given in the storage image thing, which is here. Okay, if I open this website, is my computer going to break? That does happen. Oh, it is. It's one of these ones. Well, my browser's going to freeze anyway. It's going to load for like 30 seconds or something. Maybe longer. Okay. So I think we shouldn't really be drawing straight to this. So this is an error. But we can at least confirm that it does work, which is cool. So you can see the little red square up the top left. That's our first invocation of the compute shader. Now if we do something like change this position, which is currently 0, 0, if we change it to window width divided by 2 plus minus 8, we should get a red square in the center of the screen. Nice. Okay. That's cool. Now, is this loaded yet? Yeah, apparently. Okay. Oh, thanks. I just have to click another link. What? So the error is 04152. which means the image layout member of each element of the image must be a member of the list given in this. And I thought that's what it would have been linked to, but actually it's linked to the link to that. And here it is. So we've got, okay. Image resources and image view that load, store, anatomic operations can be performed on. Stores to storage images are supported in task, mesh, and compute shaders. Yep. So we need the... Wait, what? Ah, my browser is frozen. I love this website. Okay, there we go. The descriptor type, right, of the image layout member of each image info must be a member of the list given in storage image. Okay, where is that? Ah, it's frozen. God damn it. Okay, here we go. Is this it? Descriptor set layout. Did I miss it? Was it up there? Oh man. Oh, is it this? No, it's not that. This is really painful. So much text here. It's good that it's very thorough documentation, which is great. It's just kind of annoying that it's laggy. So I've got to use this little, I've got to click this button, otherwise it seems to not like that too much. If I scroll too quickly, you know. Storage image bit, that's what we've got. I just don't see the image layout. So it's got to be one of these. Image layout, depth, stencil, read only, general. Okay, so it can't be the one that we're currently using, which is, where is it? Color attachment is not here. So it's not allowed to be a color attachment. Okay, got it. So basically, this update needs to be reverted, I guess, here. And this has to be something else. Like general. Is that right? I think that's right. Why does it matter about this descriptor set? I think this is correct, but also not correct, because we're already changing it to color attachment optimal. I'm gonna read the error again. I should copy it, because I keep forgetting exactly what it says. Okay, let's pause this. Copy this. Oh, where is it? Okay. Copy this. Is this just the same error over and over again? Yes. Copy this one then. Okay, here's the error. Nope. Here's the error. And I'll turn on wrapping, I guess. How do I turn on wrapping? Set wrap. Soft wrap enable. True. There we go. Okay. So image view of this particular descriptor set is color attachment, but okay, basically we've got to either render to a different image or I guess make a different image view to the same image. That might also be fine. So if we look at this code here, then this would have to be changed. What? And that's not the problem. The problem is, there's no option to set it here. It must be in the image itself, which is right here. Create image. No, this is swap chain create info, not the image create info. Where's the image create info? So it looks like this, and you've got the usage. But it's not about the usage, it's about the layout. Okay, I need to go to here, layout, not the push constant layout, the other one. Stage flags compute. Yeah, that's correct. Binding 0, that's all good. Descriptor type storage image. So this could be actually, no, it has to be storage image. Descriptor set. I'm just going to render to a different image and then composite them, I guess. That would be the correct thing to do. I think that's what I want to do, yeah. So when we make the image view here, we use these options. When we make the swap chain images, where is it? Oh, it's just handled by this, I guess. Right, so I put storage here at some point. Was that just now? I don't even remember. Yeah, I think it was. Alright, hang on a second. I'm going to turn the aircon on and then we'll just make a new image view and a new image to render to. And that will be much easier. And then we can just draw it on top of the other frame buffer. So, 1 second. Okay, actually I think I have a function here. Did I save this? No? I thought I had a function to make a frame buffer, which is just like a general image you can draw to, but that's alright. So we're going to make one. I suppose we'll make it here, here. It's part of the SDF compute pipeline. So I will make create frame buffer to draw to. So that's going to be create image. And we're going to store that in SDF compute image. I just call it a frame buffer because that's what I'm used to from OpenGL. So we're going to make the image type 2 dimensions. Format is going to be BGRA8 unorm. Extent is going to be the swap chain size, swap chain image size, swap chain dimensions. Yeah, that's right. That's the wrong type. Is this the 3D extent? Yeah, okay. That's fine. We'll do width equals yeah. Whoops. And depth is going to be 1. Okay, mid levels 1. Array layers. Okay, array layers. Yeah, I guess 1. Samples is going to be tiling. Yeah, optimal, I guess. Usage is going to be storage. We're also going to have to do a transfer, so I guess it'll be transfer source. Oh wait, no, we can use it as a we can use it as a sampled image and then draw it with a shader on top. Sharing mode is going to be exclusive. Actually, I should look into that. Sharing mode with what though? Let's have a look. Vulkan image sharing mode. Okay. How they can be accessed from queues. Okay, we only have one queue, so I guess that's just going to be exclusive. Queue family index count. Do I even set this? Pretty sure I don't. No, I've never set that on any of the images. Initial layout is going to be undefined, I guess. Actually, we could set it as general. That should be available in the shader, I think. So we're going to make this image. Okay, now we're going to make the image view. Create image view. So this is how you can look at the data in different ways. So you can create image views for the same data with different setups. I've never done it. Well, I don't think I've done it. But it makes kind of sense. So you could view an image as different format. So you could pack different data in different channels and stuff, I suppose. What time is it? 1:05. I think I got on a little bit late today, so yeah, I'll be here for another 20 minutes or so. Hopefully enough time to get this done. Create image view. This is a image view created for the image is going to be context SDF compute image view type D2 format BGRA 8 unorm. I actually like unorm more. I was using sRGB before, which adds gamma, so it's a different color space. I didn't even know about all this stuff until recently, but yeah, I think unorm is much nicer, personally. What's wrong with this? BGRA 8. Alright, you have to add an 8 after all of them. Sub-resource range, do I need this? Aspect mask. I have used it in depth buffer. Okay, alright, color. Okay, I got it, yeah. Oh, I have used this. Source. Oh, that's for the image barrier. Level count 1, that's also for a barrier. Here we go, image view create, color 1-1. Okay, depth 1-1, color 1-1. Okay, I guess I'll do that. This is level count 1, layer count 1, I think. Okay, and the problem is this doesn't exist. What's wrong with this? Ah, pointer, yes. Okay, we need to also allocate the memory for the image, because that didn't happen yet. Allocate memory. Memory allocate info, okay. So SCF compute image memory. I'm pretty sure we need to do this. Size is going to be, well, let me have a look. What have I done in these other ones? This is for what? That's for a buffer. That's also for a buffer. That's for a buffer. That's for an image. So I need this. Okay, that's easy. Oh man, I have a function for this. I already made a function for this. I don't need to write all that code. VK image create, and it gives you, I forgot about this. Image and the image view and the memory. Well, let's just do that, eh? Man, writing out all these structs. Okay, pass in the context, and then the image create info. Oh, I guess I needed to make this, I need to write this out anyway. That's fine. Oh, was that a pointer? I think it was. Okay, and then image view create info, which is this. Okay, and then memory property flags. This is going to be device local, I think. Yeah, I don't think we need it on the CPU side. That's it. Okay, nice. And that's going to be assigned to image, image view, and image memory. So compute image view memory equals, is that not a thing? Oh yeah, I guess I didn't make it yet. Okay, now I got somewhere to draw to. Perfect. Perfecto mundo. Alright. Okay, so now when we're doing our compute shader drawing down here, there's a lot of code again. I deleted 1500 lines the other day. Looks like we've added a lot of those lines back. I'm gonna leave this stuff for a second. I'm just gonna change this. So we're gonna draw to the SDF compute image view. And the layout is actually... That's not the layout, it's general. I don't know if that's a problem. Okay. Also means we probably don't need to do this every frame because this is not going to change now. So we can do this up the top there. So I usually would do it here, allocate descriptor sets, and then update them here. Alright. And then go back down. Where were we? Nope, 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 nope. I should have saved the position. Damn it. There we go. Okay, I think that should be good, but let's see. There's probably errors. Well, there is an error, and also we're not getting a red square because, of course, we're not drawing to the frame buffer anymore, or the one that we're presenting to the screen. So we got a problem here where create image is general, but it must be undefined. Okay, well that's interesting that you can set that in create image, I guess. So just get rid of that line. That should get rid of that error. Alright, okay. Apparently there's more errors now. So we've got here image invalid image layout with the command buffer. Right. So expected to be general, instead it's undefined. Well, yeah. Okay. It's fine. We'll use this, not that one. Where is it? Transform image, transition image. Yeah. So we're gonna use this after here. And we'll transition the image layout. Oh no, we need to do it in the... Well, we've got access to a command buffer. So I'll do it here. Even though I'm probably going to delete this code later. I'll put a big note here. Note. If I make this red, maybe I'll see it more. This needs to run for new compute pipeline. Okay, so it's going to be SDF compute image. It was undefined. We want it to be general. This should be what? The destination access? I don't know what to put in here. Top of pipe, color attachment output. No. It's not giving me autocomplete, which is annoying. I gotta go to the type. So we want it in the compute shader. Is that even an option? Compute shader. Yeah. Okay, and then here is the access flags 2. So this is for the destination. So the destination layout access flags, we need shader storage right, I think, or is it shader image right? Shader right. There's no shader image right. I think it's going to be maybe shader right. Okay, so we're going to transform it from undefined to general. The source access flags is none, but the destination is going to be, we're going to transform it into something that needs to have the shader right access flags. We're going to do it at the top of the pipeline so it's ready by the compute shader. I'm pretty sure that's what this means. And it's not a depth buffer, so I don't set that value. Okay, that should maybe work. Okay, good. I think that's working. But now, to see the image, we're going to have to open it in render doc. Because we'll be able to look at the rendered image here. So after this compute, we've got an output, we've got a red dot in the middle of the screen. That's exactly what we wanted. So we can tell that's working. That's great. Of course, this is just the first step of many. I have been working a little bit on this some night times when I have a little bit of time. Depends what happens with my daughter. If she sleeps well and if she sleeps early, then I have a little bit of time. Otherwise, I don't. So I may skip a few things, but I'll always try to explain if anything crazy happens in between. Not that I really expect anyone to watch all of these streams. That would be interesting. I kind of just want this to be here so that in the future when I release the games, there's a whole documented process of the entire thing, which I think would be pretty interesting. Okay, so we can get rid of this stuff. We're not doing this anymore. What we will need to do though is combine the images so we can see it on the screen, but we can worry about that later, I would say. So if you have a look at the compute shader now, actually maybe we can do that really quick because I've already got full screen quad, which is here, and I've got another full screen quad. So this is how I was combining it before, but I think we can actually do it differently. So this is sort of a blend, but I think we could do, well, it's not exactly a blend, but I think we just say if the sample is greater than 0, then we would display it. Otherwise we wouldn't display it because we're just doing an overlay. Yeah, so let's see. The annoying thing is we need to make another pipeline to do this. So let's just see here. It would be, hey, why are these descriptor sets getting updated here? Oh, this is the fill chunk compute pipeline that we're not really caring about right now. Alright, so yet another pipeline needs to be created, but it's a graphics pipeline. So I can probably get away with copying this. SDF compute pipeline, and I'll call it. So I actually did this before in SDL, not SDL, yeah, SDL3. I had a composite pipeline, which is maybe not the best way to say it, but I'm sort of overlaying one image on another. And so we're just going to have a sampled image or a combined image sampler. I will say a combined image sampler, binding 0, available in the fragment shader. We don't need anything else. And then what else? Obviously we have to change all of this. SDF uniform. No, we don't need a uniform. We don't need any of that. Don't need a storage buffer. And we've got to change the descriptor sets as well. So we've got combined image sampler here. We'll use that. Destination binding is going to be 0. Shader read only optimal is correct. And it's going to be the SDF compute image view. And we'll also call this the I guess we'll call it the composite image sampler. We haven't made the sampler yet. It's going to be annoying. Okay, I need to create sampler. Here we go. Oh, that's not hard. So this is going to be composite sampler, I guess. Composite image sampler. Descriptor set is going to be not that. We'll just composite. I think there's some more abstractions I can make to make this less code eventually, but I just don't want to be too hasty. That descriptor pool is fine. Descriptor set layout, we're never going to use it again, I think. So composite descriptor set, composite image sampler, and composite. Yeah, that's all we need. Okay. Just sampler, isn't it? Or sampler 2D, is it? Or is it image sampler? Damn it. Where is it? Sampler. It's just sampler, okay. In that case, I'm going to rename this to sampler. Okay, composite sampler, combined image sampler. Does it need to be combined? I don't know. I need to look up what the difference is. So I've got the SDF compute image view. Is that right? I think so. I don't think we need to make a new image view. Okay, update the descriptor sets. This is the composite pipeline. It's got a vertex shader, which is going to be full screen, quad, and then the fragment shader is going to be composite, I guess. That's all fine. That's fine. We don't really need push constants, I don't believe. Render target is going to be swap chain format. Okay, so this has to be composite graphics pipeline, which we don't have. Okay, good. We've got an error. These don't exist. Okay, gotta go to build, add GLS. I'll just copy this line actually. What am I doing? Copy the line, change this to vert, and it's full screen quad.vertex shader. Okay, and then this one is going to be composite I'm going to open that other one, full screen fragment shader here. I'm going to copy this stuff. I'm going to change this to be just the texture. This is just the color, F, color dot A, color dot A? Yeah, I guess. Hang on a second. Oops. So I'm writing to, yeah, I'm going to be writing on top of the frame buffer, the standard frame buffer. So this is just going to be color. Whoops. This will be if color.a. Actually, yeah, we'll do if color.a is greater than 0, then this. Otherwise, discard, I guess. Is that right? Maybe. I guess we'll find out. Build. Well, it builds. That doesn't mean it's correct, though. Whoa. Whoops. Okay, that's all looking good. Triangle list. Yeah, so we've still got to draw it at the end here. So we're going to bind the pipeline. I will grab, we need to do rendering, so I'm going to get this stuff as well. Not any of that stuff, just this. I think we could probably change the order of this to make it more efficient, and I will do that, I guess. This actually doesn't need to be changed at all, and we can just reuse it, I think. Yep, so we're going to load the image. We're not going to clear it. We're going to store something. Yeah, okay. This is going to be not SDF, but composite. And there's no push constants. Descriptor sets. Yep, that's fine. We're going to draw 6 vertices, yeah. Okay, is that right? Maybe. Well, we don't see the red square, which means we didn't get it right. And there's a bunch of errors. Let's have a look. Got that. Where is it? Here we go. Okay, so we're trying to draw something, but it uses descriptor set 2, which is not compatible with the currently bound descriptor sets pipeline layout. Okay. Yeah, so for each set, okay, so we got something wrong with that. All right, let's have a look. So we're binding this pipeline, composite, we're using this descriptor set. Okay. It's probably going to be by the way, I should probably add a fix me here, like wait for compute to finish. Pretty sure we got to do that. I could just do wait for device wait idle. I don't know if this would work. I don't think so, because it's a GPU to GPU, this one. So yeah, but anyway, I'll put that there. It's just a quick and dirty fence. So the problem is our composite pipeline, or composite descriptor set, rather. What's wrong with that? We got combined image sampler and the fragment shader, but it says we're using number 2. Composite descriptor set, yeah. Descriptor count 1, binding 0. Okay. Is it this? No. Let's read the error again. Okay. So, set 2 is out of bounds for the number of sets bound, which is 1. Is it in the shader? Let me have a look at the shader. I might have just... not that one, this one. Set 2, yeah, okay. Whoops. Yeah, I think that was a shader that I had in SDL3. And you had to set the set to 2, because they have static sets that you need to use for different types of uniforms. Okay, cool. We got this working now, but there is still an error. Let's see what it is. It is... the image layout specified by the descriptor sets doesn't match the actual image layout at time descriptor is used. Okay. Because when we call draw, we've specified cannot use image with specified layout shader read only optimal, as that doesn't match the previously used layout general. Okay. Yeah. All right. So where was that? General. Let's just go down. I thought we did transition that image, but I guess not. So, oh, we need to transition it again. I think. Which image is it talking about? It must be this one. So we've transitioned it to general, and then we've used it in the compute shader, but we also need to transition it here from general to crap, what did that arrow say? It's not giving me IntelliSense again, or whatever it's called. So we want to transition it to a particular layout. So we need to look up the image layouts. So we want it to be shader read only optimal, right? Yeah. So the source flags, I guess, is going to be shader read, right? I guess. No, the source flags shader write. Destination flags shader read. And the source stage is going to be compute shader, and then this has to be bottom of pipe, I think. Is that right? No, apparently not. Let's have a look. Okay, so problem is the destination access mask read is not supported by bottom of pipe. Right, it must be graphics pipeline all stages, acceleration structure. Okay. What if I just delete that? Do we need shader read? It's actually not. It's actually sample, isn't it? Shader sample read. I think I can just get rid of that. I think. This was running. Build again. Almost there. I think. Okay, so we got another error, validation error, because if the destination access mask includes read, the destination stage mask must include. Okay, I didn't read that part last time. One of the stage something shader bit stages. I see. So not bottom of pipe. I suppose that makes sense. So we actually need it by the fragment shader stage. Oh, God damn it. Where is it? Is it just fragment shader? Yeah. Still got an error. I mean, it's working, but it's just not correct. VKQ submit. Okay. So when we submit this image layout is in shader read only, but it should be in general. Is that right? No, it should be in general, but it's in read only optimal. Shader read. Oh, yeah. Okay. So after we do the rendering, we've got to transition it again back to general because that's what it's expected at the beginning. So this would be, I guess, just swap these. Actually, you know what? I can find the other one. Where is it? Here. Paste this. So I think you can still do undefined, but since we know the type, I'll just put it in here. Shader read only optimal. And we want shader right. What's wrong with that? I missed something. Ah, somehow I deleted that. I think this is still going to be wrong. Well, it's not complaining to me. It doesn't feel right to me, though. Cool. All right. Well, I'm going to say that is kind of successful for the stream. Everything always takes longer than I expect. But that little red square is being drawn with the compute shader and being composited onto the top of the image. So in the future, the idea would be this compute shader can share between 16 by 16, which is, what is that? Is that 4,000 and, no, that's 16 by 16 by 16. What is 16 times 16? Is it 256? Yeah, okay. 256. 256 threads can share the same memory. So we're going to put local memory in here. We're going to have like local Voxel bit field or something. Or like even just like a local int or bool Voxel exists. And we can put in 16, not 16 by 16. We'll do a smaller group of like, I guess it depends how much memory you can share. I'll have to look into the amount that you can share between threads, but that should allow us to cache a lot more of the results in here. Share those between 256 threads, which is great because we just need to read from it. So in the first one, we're going to do something like if gl.local invocation id.x is 0, and I think there might be another I think there might be an index, not just an ID. Invocation, God, I can't type. Anyway, we're gonna basically just check if we're on the first one, and then we'll do fill shared memory and barrier. There's a way to do a barrier. I don't remember what exactly the function is called. It might just be barrier, it might be something else. So that way the first thread will do anything in here, and then it will, all the other ones will wait for it, and then once it's done, they can all do the rest of the calculations, which will be all of the SDF stuff in here. So yeah, that's the plan. Hopefully it works well. Hopefully we can get a much better frame rate. Hopefully I can stop lagging on stream. That would be great. And that's about it. So I want to thank you guys for tuning in, and I'll see you next time.